Hello, good morning. Today I will be discussing on prime number calculations. This is a part of teaching mathematics in 21st century, and myself Chanchal Dass. I am chairman of Das Scientific Research Labs Private Limited, and I am researching on making mathematics uh, popular and simple to understand. Today I will be dealing with Sieve of Eratosthenes 2300 years ago algorithm for calculating prime numbers in contrast with the same explanation with present day technologies. So my main focus will be on the uh, uh, algorithm given by Eratosthenes around 2300 years ago, and now we will be doing same thing we using Microsoft Excel. Here my course on mathematics. Mathematics is for solving the real life problems, and mathematics is not for puzzling the pupil. So this is the thing actually. When we learn any mathematical concept, we keep it in mind, and with this my objective here is to apply a new approach of teaching mathematical concept. It is not the applied mathematics, a mathematics in applied way. So what I am trying to do, I am trying to change the perception of mathematics. At present, if I talk something, ask some student what is mathematics, something many symbols, equations and formulas come in our mind. But if we see this through geometrical perspective, then all mathematical concept will become either a point or a line or a surface or a solid. And in this case, the mathematics will become very limited things. When formulas, symbols, equations are appears to be infinite things, then geometrical representation of all those formulas, equations, symbols can be very limited things on points, lines, surfaces and solids. And in that way, if we learn mathematics and we can perceive mathematics in that way, geometrical way, mathematics will become very simple to learn and understand. So with this objective, I have created a Das Math Lab, and we are promoting this simplified mathematical concept through this Das Math Lab. And our objective is to be world leader in simplification of advanced mathematical concept. We are not dealing with any new concept of mathematics and no fundamental research. We are working on the mathematics which we already know, and we are trying to simplify all those concepts in such a level that everyone should understand and enjoy the beauty of the mathematics. So what is the difference between this pageant way of teaching mathematics and geometrical modeling and animation way of teaching mathematics? Actually, if we see that the world has changed from no technology to advanced technologies. Earlier there was no technology available to solve mathematics, but now there are lots of technology available to solve the mathematical problems. So we can concentrate much more now on concept understanding than problem solving. For problem solving, there are many tools available. Some of the tools are Microsoft Mathematics, MATLAB, Mathematica, Scilab, GeoGebra, Google Calculator, and like that many other things. So now we should concentrate our thoughts on what should be the calculated, not how to calculate. So prime numbers and sheaf of Eratosthenes. Prime numbers are introduced in class 6, and as far as definition of prime numbers is concerned, prime numbers are defined as the numbers which has only two factors, 1 and the number itself. From this definition, 1 is not a prime number because it has only one factor, that is 1. The number 2 has two factors, 1 and 2, so it is a prime number, and the number 2 is the only prime number which is even all other prime numbers are odd. So when we start the learning mathematics and particularly prime numbers, it starts in class 6, and in class 6 you can see that it starts with the geometrical pattern of the numbers. If we see right side of the numbers, all these numbers can be represented geometrically by 4 different shapes. These shapes are line, rectangle, square and triangle. So this 2 is only we can represent by a line, 3 can be represented by a equilateral triangle and a line, 4 can be represented by a square or a line, 5 can be represented by a line. Similarly, 6 can be 2 by 3 or 3 by 2 or 1 by 6. So like that, every number can be represented with a line, rectangle, square and triangle. So the advantage of seeing all these figures is that we can very easily find out some patterns that the number carries. So if we see that number 2 has only represented by 1 into 2 or 2 into 1, so like that two ways it can be represented. Similarly, line 3 can be represented by a triangle, equilateral triangle and a line. 4 can be represented by 2 by 2 lines, square and 1 line. Similarly, 5 can be 1 line. So like that, if we go on increasing these numbers, then we will see that there are many things, and from that one concept comes which is called factors and multiples. So these factors and multiples are introduced in chapter 3 of class 6 in the NCERT book, and it defines that a factor of a number is an exact divisor of that number, So 6 has can be divided by 1, or 6 can be divided by 6, or 6 can be divided by 2, and 6 can be divided by 3. So 6 has 1, 2, 3 and 6 factor or 4 factors like that. So 1 is a factor of, if I see that 1 is the factor of every number, and every number is a factor of itself. So every factor of a number is an exact divisor of that number. These are the few definitions actually which is required to when we explain what is prime numbers. In that way, every factor is equal or less than the given number. Number of factors of every number is finite, and multiple, a number is a multiple of each of its factors. Okay, so these are the few definitions, and with that there is a prime number, the numbers whose only factors are 2 and the number itself, and some examples I have given. It is 2, 3, 5, 7, 11, 13, 17, 19, 23, like that, all these numbers, and all the other numbers which is 4, 6, 8, 9, 10, 12, all are the composite numbers. So with that background, we can see this prime, how we can find the prime numbers, and here we will be dealing with sheaf of Eratosthenes, which was written by him around 2300 years ago, and still it is very uh, relevant for calculating prime numbers. So it is that prime number plays a very important role in our daily life. It is an important activity to find out number of primes up to a given number. Number of primes below number 10 is 4. Suppose I want to know that how many prime numbers are there below 4, below 10, it is 4, and these numbers are 2, 3, 7, 5, 7. Many times we require to find out the numbers of primes below a given number, like below 100, below 200, below 300, even below 10,000, 1 million, like that we want to calculate that. But manually it is not possible. So Eratosthenes has provided us an algorithm, and that is very helpful in calculating the number of primes and all the prime numbers below a given number. The algorithm is called sieve of Eratosthenes. So it says that first you list out all the numbers up to which you want to calculate that prime numbers, and then cross out 1 because it is not a prime number, encircle 2 and cross out all the multiples of 2 other than 2 itself, that is 4, 6, 8, all these numbers will be crossed out, and then you will find that the next uncrossed number is 3, encircle 3 and cross out all the multiples of 3 other than 3 itself. Then the next uncrossed number is 5, encircle 5 and cross out all the multiples of 5 other than 5 itself, and continue this process till all the numbers in the list are either encircled or crossed out. All the encircled numbers are prime numbers. This method is called the sieve of Eratosthenes. This is very good, and manually we can check it up to certain number, but when this number increases, then it is become very difficult to calculate manually. So here we have used MS Excel to calculate these things, and the steps followed are these. Here these are the steps we have followed. There are 14, 20 steps, but it is very difficult if I go to explain all these steps. So I am directly going to the Excel sheet and explain how this sieve of Eratosthenes work in. So this is the file where I have calculated all these prime numbers up to a given number. So for that, what I have done, I have put a slider here. This is called slider. Here I can check the number n. N means what is the number up to which I want to calculate the prime numbers. So here I have used some of the keywords. You can see that up to 3 there is only one keywords, up to 3, not including 3. So up to 3 it is 2, and then if I close up to 4, 5 there is 2, and this is shown here. You can see this. So this is K to M1 cell. M1 cell they are displayed number of primes, and below n is 5, and that n is given by this . this is the from slider, this is the 5. So below 5 this there are 2, and this is also shown graphically. Here you can see this up to graph, this is the upper limit I have put 5 up to 5. So up to 5 there are 2 prime numbers, 2 and 3. Now if I increase the slider up to 6 also there are 2 primes, up to 7 there are 2 primes, but up to 8 there are 3 up to 10 there are 2, 5, 2, 3, 5, 7 are the primes. So 4 primes. So if you go on increasing this number, you will find up to 13 there are 5 prime numbers, and up to 14 6 prime numbers. 1, 2, 3, 5, 6. Yes. So now up to 15 it is 6, up to 16 it is 6, up to 17 it is 6, and up to 18 it is 7. So like that I can you can go on dragging this slider, and you can find out up to 100 how this we can see this number of sliders here. Here you can see up to 50 you can up to 50 we have 15 prime numbers, and these prime numbers are shown graphically also. So you can see this, somewhere these numbers are very close to each other, somewhere the distance between two numbers are very wide, and all these things can be easily calculated automatically when you work on so up to 70 there are 19 prime numbers. Let us check up to 80. Up to 80 there are 22. Up to up to 90 there are 24 prime numbers, and up to 100 you can see 100 up to 25. Up to 100 the prime numbers are 25 prime numbers. So these are the things, and the calculation part, if you find that this calculation part, here I have first in this B 5 to 104, these are the cell. First cell I have arbitrarily taken the numbers 1 to 100. This is the thing I have taken serial number 1 to 100 like that, and then what I have done in second column, C column, I have taken 1 as it is not a prime number, I have made it blue, and then 2 I have taken with a condition. This 2 is the first prime numbers, and if B6 is this number is less than C3. C3 is the this 100. C3 is the n, and below C3 then write C3, and otherwise put your 0. This I am doing to ensure that I should take a number below 100, not including 100. So if last number is 99, so this is up to 99 we want to calculate the prime numbers, so 100 is excluded. For this purpose I have used this formula. Then I have checked that which is the first prime numbers, and we know that this first prime number is 2. So this 2 I have taken from seat 6, and this is the C6 I have taken here, and then I have checked whether this D2 is less than or is equal to n means D3. So this is required because we are calculating the prime numbers, no. So if n is a prime number and if it has two factors, so one of the factors should be less than the square root of that number. So for that we are ensuring that this number should not be more than square root of n. So that formula I have used here, and rest I am calculating from C3, because C3 we know already it is a prime number. So green D5 I have put this, and then D7, you can see the D7 I have calculated. If D5 is greater than 0, so D5 is I am cross checking that D5 should be greater than 0. Then I am calculating all the multiples, means I am calculating all the mod of these two numbers, and this mod is from is a integer division. Actually it is an integer division. So 3 is not divisible by 2, so it is putting 3 itself. 4 is divisible by 2, so it is putting 0. So those numbers are divisible by 2, it is putting 0, and all the numbers are not divisible by 2 is remain intact. So this is the first strip, and then this 3 E2 I have taken from this number D7. D7 is the first, this is the D7, this is the first uncrossed number that I have taken here, and then again I crossed that whether this number is here, if this number is less than square root of n. If it is square root less than square root of n, then we will put take the number, otherwise we will take this 0. So green, this is E5, and then E6 and E7 we have taken that from the previous cell, and subsequently we have checked whether this all the remaining numbers are multiples of 3 or not. So for that again we have used same mode function, and in that case you can see that all the multiples of 3 are vanished here. So in that way, next cell I have taken that next uncrossed number is 5, and then I have cross checked it in this F6 F5, that whether it is a square root less than of square root n or square root of 100. So it is less, so it is taken 5, and then we have copied up to say 5, that all these numbers already we have checked. Now remaining numbers we are calculating whether this is a multiple of 5 or not, and you can see that all the numbers remained which are multiple of 5, as one see that 15 was there, multiple of 5, 15 not 15, this 25 was there which is multiple of 5, so it was made 0. Like that, if you go on finding that this was 35 was multiple of 5, so it has become 0. Like that we have calculated. So in that way, next we have taken the F11. F11 is the next unchecked or number which is not which is prime, and that number again we have checked in G5. we have checked that whether it is less than a square root of 9 or square root of 100 or not. So it is less, so it is taken here, and then same process as we have checked, all the numbers multiple of 7 was removed from that, and in this way next uncrossed number was 11. So next uncrossed number was 11, and this number again we have taken here in H2 cell, and then we checked whether this H2 cell number is less than square root of 500 or not, and it is less than 500, so less than square root of 100, so it was made 0. So when we made 0, then we should not go further for calculating same thing. So the numbers which is remained unzero numbers, all the numbers which is not 0 are the prime numbers. This is the thing up to 11, so up to 100. So this way we can calculate all these things. Again I am explaining this. Now if I reduce this number, suppose again I will go back to 0 using this slider. So you have to keep this. I am putting it a green sign here. So this is the 0, and up to 0 there is no prime number, and M1 this is M1 cell you can see, and you can see this B2 cell. So these two you can see, this is the up to this is N, up to N there is no prime number, and if I go on up to 1 there is no prime number, you can see from M2, then up to 2, up to 2 there is no prime number, but up to 3, up to 3 there is a prime number. So like that it is 2, and if we go for 4, then there will be 2 prime numbers. If it is 5, then there is no prime number. It is 6, there is again 2 prime numbers. So it can go on like that, and you can find out all the prime numbers from this. I think this is the modern way of learning mathematics, and one time a student know this, what happens here, they will always remember how to calculate and what goes on when we calculate the prime numbers. And thank you for this, and all the steps whatever followed are given in the presentation, so you can check this presentation also. Thank you.